Hey everyone, so we are back with another video regarding operating systems. Specifically today we're going to be talking about multi-level feedback queues, or MLFQ. And MLFQ, or multi-level feedback queues, are used as a method for scheduling jobs on an operating system or a server. So we're going to dive into this here. So this idea of a multi-level feedback queue stems from the question, how can we design a system that minimizes response times for interactive jobs and minimizes turnaround time without knowledge of job length for more CPU-bound jobs at the same time? What we're trying to do is essentially predict the future based on the past. And the MLFQ is a way of doing this. Not perfectly, but as best we can. So let's talk about some of the basic principles associated with the multi-level feedback queue. So with the multi-level feedback queue, there is a number of distinct queues, each with different priority levels. So generally we work our way from high to low priority levels. The top is high, low is the bottom when you're modeling in a diagram. Priorities are used to decide which job should run at a given time. So priorities are assigned to jobs, and then according to the priority that is given, it's put in one of these queues associated with the priority. And what we find is jobs with a higher priority are always chosen to run over jobs with lower priority. However, obviously, given that the data structure we're using is a queue, it's possible that more than one job may be on a queue at any time. And so in this scenario, we use round-robin scheduling. And round-robin scheduling is really simple form of time sharing. We basically allot the same amount of time to each process in this entire queue across the board. So all of these jobs in the queue are going to get serviced at some point. So now we got to ask the question, how do priorities change over time? We don't want to just give it a job one priority when it enters the system and then have it maintain that priority for the rest of its time span. We don't know a lot of information about the job yet, and so we need to get some of that information over time and then change the priorities accordingly. So when a priority enters the system, we just simply by default place it at the highest priority level. If a job uses the entire time slice while running, its priority is reduced. So if it isn't preempted, if it doesn't just give up the CPU, if it uses the entire time slice, that's not a good sign because it's suggesting that it's not an interactive job. It's more of a CPU-bound job. So yeah, point 3 comes right to that. If a job gives up CPU before time slice, it stays at the same priority level. So let's say there's some I/O needed, and so the job comes to a halt and it's waiting for that I/O. That's a good sign. It means we need to keep response times quick for that job, and so we're going to keep it at that priority level. We're going to keep it at a higher priority level. But this setup has one fatal flaw, actually, and that's some of these jobs can starve. If too many interactive jobs enter the system, long-running CPU-bound jobs might not ever get any time on the CPU. And so we have to introduce some rules to our MLFQ to avoid starvation. So here's where we get rule number 4. After some time period T, increase the priority of all jobs. So for simplicity, the way we're going to do this is we're simply going to move all jobs to the topmost queue. This way all jobs get serviced because they're all in the same queue, and we come back to the round-robin approach for this queue of jobs. And the other great part about this too is if CPU-bound jobs later become interactive, they have a chance to have their priority reflect that. And then rule number 5, all jobs get a time allotment at each level. There's a certain amount of time any given job can spend at each level before it has to reduce its priority and move down to a lower priority queue. It does not matter how many times the job has given up the CPU, prematurely. This is irrespective of that. And since jobs, rule number 6, since jobs are more CPU bound, the lower we get in priority, lower priority queues should have longer time slices. This is another rule that we put in place in order to optimize this whole process here. So that is a very brief introduction into multi-level feedback queues. I hope it made sense. If there's anything you think I should have elaborated on, or any questions that may have came from this brief video, please do leave it in the comments and help out the rest of the community that's trying to learn about some of these scheduling policies. Thank you.